Hi everybody, today we're going to do a hypothesis test for the test of two variances using Minitab. Our problem says a company is doing hypothesis test on the variation of quality from two suppliers. Both distributions are normal and the populations are independent. We're going to use an alpha of 0.01. Our null hypothesis is that the variances are equal. Then our alternative hypothesis is sigma 1 squared is greater than sigma 2 squared. We have two samples. The first sample has 26 items with a standard deviation of 3.7609. The second sample contains 14 items with a standard deviation of 8.7634. Don't let the wording confuse you. Just because we have first sample and second sample, that doesn't mean first sample is sigma 1 and the second sample is sigma 2. Instead, when we go to do the degrees of freedom, we need to look at the standard deviations. Sample 1 has a standard deviation of 3.7609. Sample 2 has a standard deviation of 8.7634. Because 8.7634 is larger, we're going to use this in the numerator. To get the degrees of freedom, we look at our 14 items and we subtract 1. This is degrees of freedom in the numerator is 14 minus 1, which is 13. For the denominator, we look at the 26 items, and again we subtract 1. 26 minus 1 is 25, which is the degrees of freedom in the denominator. To find the F ratio, we need to divide the variances. That means we're finding S1 squared over S2 squared. So we'll start with 8.7634 squared, then we'll divide by 3.7609 squared. In a calculator, we'll put 8.7634 squared, then we'll divide by 3.7609 squared. If it's easier, you could start with 8.7634 divided by 3.7609, then square the entire quantity instead of squaring the terms individually. In both cases, we get 5.4295. Now that we have our test statistic, we're ready to go to Minitab to find our p-value. To get the p-value in Minitab, we have a few steps to follow. We'll start by selecting Graph, then we'll go to Probability Distribution Plot. From there, we select View Probability. Once we've opened this window, we need to change the distribution to an F distribution. This will let us put in our degrees of freedom and our F statistic. Let's take a look. From Minitab, I'm hitting Graph, Probability Distribution Plot, View Probability. We'll switch from a normal distribution to an F distribution. Here, I'll put my degrees of freedom, 13 in the numerator, 25 in the denominator. For the options, we're putting in a specified X value, which is our F ratio. We had 5.4295, and we're doing a right-tail test. This gives us a value of 0.0001494, which I'll call 0.0001. In conclusion, our p-value of 0.0001 compared to our alpha of 0.01 shows us that p is less than alpha. We know that anytime p is less than alpha, that we will reject the null hypothesis.